2.2. Solving one-step equations. We'll get to multi-step equations, but it's good to go ahead and take some time and just focus on one-step equations. Why do you think they're called one-step equations?
Use the one step.
Just takes one step to solve them. Okay? So, when we're solving equations, well, first off, what did we say an equal sign means? Equals. The two sides of the equal sign are the same. They're equivalent. They're equal to each other, right? So, whenever we're solving equations, we use what's called inverse operations. Can everyone say inverse operations?
Inverse operations.
Inverse operations. Inverse just means opposite. So what's the opposite of addition?
Subtraction.
Subtraction. What's the opposite of subtraction? Addition. What's the opposite of multiplication? Division. Opposite of division? Multiplication. So to solve equations, we use these inverse operations. Okay? If I do something to one side of my equation, I've got to do to the other side as well, because the equal sign means that these two things are the same. So if I do something over here, but don't do it to this right side either, then it's no longer equal, correct? So whatever I do here, if I add 2 over here, I've got to add 2 over here to keep it equivalent, to keep it the same. If I divide a side by 2, I've got to divide the other side by 2 to keep it exactly equivalent. Does that make sense? It's like a balance. You guys ever seen a balance or a scale where it's got 2 sides right here? You try to keep it equal. If I add weight over here, this side's going to go down, this side's going to go up, right? So to balance it out, what do I have to do? Add the same amount over here. If I multiply this side by 3, it's going to go down, this side's going to go up unless I multiply this side by 3 as well. Okay? So you can think of an equation kind of like a balance scale like that. Are there any questions before we dive into it? Okay. To solve an equation means to find all values of the variable that makes the equation true. So when I'm solving an equation, I'm solving for a variable. I'm trying to get a variable by itself on one side of the equation. Each value that makes an equation true is called a solution. Everyone say solution. Equivalent equations have the same solution. So, to solve an equation, I'm finding all the values of that variable that are going to make that equation true. So, here's our first 2 properties here for solving equations. The first one is called the addition property of equality. If a number is added to each side of a true equation, the resulting equivalent equation is also true. So, the example they give you is A equals B. It means A and B are the same thing, right? If that is a true equation, then if I add the same thing to both sides of the equation, C, that's also going to be true as well. So A plus C equals B plus C. In other words, I added one thing to one side of the equation. I've got to add it to the other side as well to keep it a true equation. Any questions on my addition property of equality?
No, sir.
We good? Okay. Second one's very similar to it, just using subtraction. Subtraction property of equality. If a number is subtracted from each side of a true equation, the resulting equivalent equation is also true. So if I have A equals B, if I subtract C from one side, I got to subtract C from the other side as well to keep it true. Any questions on my addition or subtraction properties of equality for solving equations? How do I feel about that so far, that concept? Good? Okay. Can I move on, or do I need to give you a little more time? Okay, I'll give you a little more time here. For time's sake, I am going to go ahead and move on. Once again, these properties are direct from the textbook. So, example 1. Use the addition property of equality to solve G minus 25 equals 113. Okay. When we're solving an equation, our goal is to get the variable completely by itself on one side of the equal sign. What's my variable here? G. Variables are just numbers, or letters representing numbers, right? So G is my variable here. Which side of the equation is it on, the left or the right? Left. I'm going to cover up this right side. Is that G completely by itself right now? No. What's with it?
Minus 25.
Minus 25, right? Remember, I said we're using inverse operations. Inverse means opposite. So if I'm subtracting 25 from G, what's the inverse of subtraction? Addition, right? So to get G by itself, I'm going to use my inverse operation of addition. I'm just going to add that same number. Because what's negative 25 plus 25? 0. It cancels out, right? That's why I'm using the inverse operation to get that number canceled out on that side with the variable. That way I can get the variable by itself. Everyone okay with that? Okay. Well, G minus 25 is the same as it equals 113. I've just added 25 to this side of the equation. So what do I need to do? I've also got to add, excuse me, 25 to the right side of my equation. You okay with that? Yeah. To keep it equivalent, whatever I do to one side, I've got to do to the other. Okay? So, on the left side of my equal sign here, 25's canceled out. What am I left with?
0.
G, right? I've still got that G that I've got to account for. So that's all that's left over because my 25's canceled out. We okay with that left side?
Yes.
Okay. Right side, I can combine any like terms that I have now. Are these two things like terms?
Yes.
Yeah, they're both constants. I can combine a constant with a constant. Constants are like terms with each other. So what's 113 plus 25? 138.
Oh, 8.
Is my variable now completely by itself on one side of the equation?
Yes.
Yep, that's what I want. That's my answer.
That actually makes sense.
That's it. That's it. That's all we got to do here. We okay with that?
Yes. Hey.
Any questions?
Can I use the restroom?
I need you to wait a little longer, please. If you can. If it's an emergency, go ahead. Okay. Are there any questions on example 1 here?
No.
Can I move on?
Yes.
Example 2. We've got 27 plus K equals 30. Wants me to solve this equation. What's my variable? K. Is it on the left or right side of the equal sign?
Right. No, equals left.
Left. It's on the left of my equal sign. Is K completely by itself on the left side? No. So to solve it, I've got to get K by itself. What's on the same side of the equal sign as K? 27, right? It's 27 plus K. I don't want you to get caught up on this plus sign right here. This plus sign is making K positive. Does that make sense?
Yes.
Is there a sign in front of 27? No. So would it be a positive or negative 27? Positive. It's being added to K. So, in order to cancel that 27 out, what would I need to do to it? Subtract it. Are we okay with that? Because what's 27 minus 27?
0.
0. It cancels out. This is an equation. 27 plus K is the same as 30. I just subtracted 27 over here. So what do I need to do now?
Subtract 27 from 30.
Subtract 27 over here. I've got to do the exact same thing that I did to the left side of my equation. The exact same thing. Not different signs, not different operations, doing the exact same thing. Does that make sense?
Yeah.
Left side of my equation, what am I left with?
3.
Left side. Okay. The 27s cancel each other out. All that's left over is K. Are we okay with that? Now, the right side, do I have any like terms that I can combine? Yeah. These are two constants. I can combine them. What's 30 minus 27? 3. Is my variable now completely by itself? There's my answer.
I'm pretty sure we did this last year, but it was like bigger problems.
We're gonna add to it later on. For today, we're just focusing on one-step equations. One step are the easiest because you only got that one step to do. Okay. Do you guys know how I could check my answer to make sure it's okay? Anyone know how I could check my answer to make sure that it's correct?
What did your calculator?
27 plus
Yeah.
30.
I can plug it into my original problem. I can replace k with 3 because that's what I'm saying k equals. Right? What's 27 plus 3? 30. Does 30 equal 30?
Yeah.
Yep. I know my answer. Checks out.
Alright.
I could have done the same thing on this one. 138 minus 25 equals 113. What's 138 minus 25?
113.
113. Do those equal each other?
Yeah.
They do. It checks out. To check your answer, you can always plug it back into your original problem. If you get a true statement out of it, you know you've done it correctly. Questions on examples 1 and 2?
No, I got this now.
We got it down?
Yeah. Very.
That's good. Word problem.
Can I throw this away?
Quickly. Word problem. In tennis. Anyone play tennis? All right, there we go. So in tennis, the Grand Slam tournaments are the 4 most prestigious annual events. At one point in his career, Roger Federer had won 3 more Grand Slam single titles than Rafael Nadal. If at that time Roger Federer held the record for the most Grand Slam singles titles won with 17, how many Grand Slam singles titles had Rafael Nadal won? A lot of information there, right? So we know, let's talk about writing an equation here. Remember we did that Friday. We need to identify all our knowns and unknowns, right? So we know that Roger Federer won 3 more Grand Slam singles than Rafael Nadal. At that time, Roger Federer held the record for the most Grand Slam single titles won with 17. Right? So what's my unknown here? Yeah, I'm trying to figure out how many Grand Slam singles titles Rafael Nadal won. We know Roger Federer had 17, and he won 3 more than Rafael Nadal. So how could I come up with an equation with all that information here?
17 minus T for
T
titles.
equals, hold on. Word. 14.
You're close. You guys are close. Okay? It wants us to complete the table, but the book's already completed it for us. To write an equation that represents the number of Grand Slam singles titles Rafael Nadal won. So let's talk about this table here. So the equation they came up with is 17 equals n plus 3. Okay? So n is representing the number of singles titles Rafael Nadal won. Some of y'all use t. If it did not specify a variable for you to use, you could pick whichever variable you would like. In this case, they just use n. So 17 was the record, right? That's what it said. At that time, Roger Federer held the record for the most Grand Slam single titles won with 17. So my record equals the amount that Nadal won plus 3 because Roger Federer had won 3 more. 3 more would be that plus 3. Does that make sense? So I take the amount that Nadal won, add 3 to it, and I get that record of 17. Some of y'all were saying 17 minus something. If you did 17 minus n equals 3, that would still work. Okay? But for today's purposes, we're doing one-step equations. If you wrote it like the one that I wrote there, that would actually be 2 steps to solve that equation. So let's deal with the equation that the book gave us. Okay? This is only going to take us one step to solve. So first off, is there any confusion or questions how the book got 17 equals n plus 3?
No.
The number that Nadal won, which we don't know yet, plus 3, because that's how many Federer won more than Nadal, equals 17, which was the record. So, the book completed the table for us to write the equation. Let's actually solve this equation now. What's my variable? N. Which side of the equation is it on?
Right.
The right. So let's look at the right side of the equal sign. Is n completely by itself?
No.
No. What's with it?
3.
3. What's happening between n and 3?
Addition.
Addition. So in order to get rid of that 3 that's with the n, what do I need to do with it? Subtract, because that's my inverse operation, right? Inverse of addition is subtraction. And I know 3 minus 3 gives me 0. It cancels out. These two sides of my equal sign are the same. They're equivalent. I've just subtracted 3 from the right. So what else do I need to do? Subtract 3 from the left. So on the left side, is there anything I can combine?
Yes,
Yeah, 17 minus 3 gives me
14.
14. What's left on the right-hand side of my equation? N. So, Rafael Nadal won 14 Grand Slam singles titles. Does that make sense? Any questions on example 3? We okay there? All right, moving on. So, we've dealt with addition and subtraction, solving equations, correct? Now we're going to talk about multiplication and division. Same concept. Whatever I do to one side, got to do the other to keep it equivalent. You can also use the multiplication property of equality and the division property of equality to solve equations. So that's all this is saying. If I've got A equals B, if I multiply one side by a number, I've got to multiply the other side by that same number to keep it equivalent. So I multiply left by C, I've got to multiply the right by C as well. Same thing for division. If I have A equals B, and I divide the left by C, I've also got to divide the right by C. Okay? Once again, these are inverse operations. What's the inverse of multiplication? Division. What's the inverse of division? Multiplication. Do I need to spend some more time on this so you can kind of write a little bit?
No.
Or are we good?
We're good.
You can get it from the textbook?
Yeah.
Okay. Okay. Solve each equation. Solve each equation. Letter A. 3 over 8 times x equals 9 over 4. Oh, we got some fractions here.
Oh, heck no.
Heck yes. I am excited. I love fractions. There's actually two ways you could approach this problem. You could approach it with multiplication, or you could approach it with division. I'm going to show you both ways to approach this problem. What do you guys want to do first? Any ideas here? Yep.
Wouldn't you do 8 over 3 to cancel out?
What about 8 over 3? What would I do with 8 over 3?
Multiply.
Yes. So, here, I've got 3 over 8 times x. We've talked about the reciprocal a little bit in here before, correct? What's the reciprocal of a number?
Opposite. Well, flip.
Flipped. It's a fraction flipped, right? What happens when I multiply a number by its reciprocal?
You get 0.
Not 0.
1.
You get 1. Okay? So, if I multiply 3 over 8 by 8 over 3, what's that going to give me? 1 x, or just x, which gives me the variable by itself, correct? Whatever I do to one side, got to do the other. So I'm going to multiply the right by 8 over 3 as well. Do we remember how to multiply fractions? Anyone? No, don't say butterfly.
Across.
Yeah, straight across.
A word?
I multiply the numerators together, I multiply the denominators together, and I simplify. Okay? So, multiplying the numerators, what's 9 times 8?
74.
72. What's 4 times 3? Multiply my denominators. 12.
Oh my gosh.
Now, what's 72 divided by 12? It does give you a whole number. Put your phone away. Put your phone away. Put your phone away. 6. X equals 6. Are we okay with that?
Yes, sir.
Can I erase this method and show you the other method you could use here?
Yes.
I'm going to show you both methods either way.
Okay.
Ready or not.
Okay.
Can I erase it and do it?
Yes.
Okay. Another way you can approach this, 3 over 8 is being multiplied by x, correct?
Yes, sir.
What's the inverse of multiplication? Division. So I could divide by 3 over 8 to cancel it. Whatever I do to one side,
You must do the other.
got to do to the other. In your calculator, you type in 9 over 4, divided by 3 over 8. It'll also give you 6. Okay. With a calculator, it is easier. If you didn't have a calculator, you'd have to do some other stuff. No, you wouldn't be doomed. Any questions on letter A here? Once again, how could I check my answer? Plug it back in, substitute 6 for x, work it out. If I get the same thing on the left as I get on the right, it's a true statement. It's a true solution. Questions on A?
No.
Okay, letter B. 42 equals negative 14y. What's my variable here?
Why?
Y. Is it on the left or right of the equal sign? Right. Is y completely by itself on the right? What is with it?
Negative 14.
Negative 14. What's going on between negative 14 and y?
Multiplication.
Multiplication. Let me finish saying my statement before we answer. I'm glad you're eager about it though. There's multiplication going on between negative 14 and y, correct?
Yes.
What's the inverse of multiplication? Division. So in order to cancel this out, what do I have to do to it? Divide. The opposite of multiplication, which is division. We've got to divide by that number that's being multiplied by y. And the 14s cancel each other out. Whatever I do to one side, got to do the exact same thing to the other. So I've got to divide the left side by negative 14 as well. 42 divided by negative 14 gives me what?
Negative 3.
Negative 3. What's left on the right side of the equation? Y. Because the negative 14 is canceled out. The variable is now completely by itself. I've now solved my equation. To check it, I could plug negative 3 back in for y. I would get 42 equals 42, which is a true statement. Questions on example 4? We okay?
Yep.
Can I move on? Wait a second. Oh, that's it. That was my last example. Look at that. How we feel about solving one-step equations.
Good.
Hopefully, really good. Y'all chill for me for a second. Keep your computers put away real quick. Quit getting stuff out of your bag and in your bag. Just a quick recap here. Equations mean the left side is equal to or is the same as the right side, correct?
Yeah.
So they're the same. Whatever I do to one side, got to do to the other. Opposite of addition is subtraction. Opposite of subtraction is addition. Opposite of multiplication is division. Opposite of division is multiplication. So, in order to get a variable by itself, we've got to see the operation that's going on between a variable and a number and use the inverse of that operation to undo it, to get rid of it, right? My end goal is to completely get the variable completely by itself on one side of the equal sign. Are there any questions about any of the notes we just took before I end the recording?